Varun Aggarwal. Mr. Varun Aggarwal is a vice president at EXL, and he leads a team of 150 plus data scientists in his company. And he has over 14 plus years of experience in consulting and advanced analytics. And he has been a problem solver for complex problem solver for Fortune 500 companies across banking, telecom, and utility sectors. And over the years, he has also published research papers that have been presented in international conferences based on data analytics. And he has also bagged prestigious awards at EXL for his work on intellectual capital development and analytical products. So it's a pleasure, Mr. Varun, to have you here at the session. So I just request you to please take the session ahead. We can start now.
Sure. I think we have a critical mass to get started.
Yes. Before that, I'll just request every participant to please switch on their cameras so we can have a healthy and interactive session here. And everyone is free to ask questions if they come across any. Please start, sir.
Okay. Thanks, Pratibha. So first of all, let me start with a small, I would say a small game. Let's start filling up this sheet, right? So basically what we need to do here is to write down all those keywords that come to our mind when we think about analytics. And this is not something which I want you to be an expert at, because you are here from different diverse backgrounds. Probably you're having this session for the first time, or probably you are a seasoned analyst. You can be a mix of people. However, it will be helpful for everyone to know what you know about analytics. And one small request here is that try to relate all those words with these letters only. And let me get started. So let's say we make data as a base of analytics, so, right? And we do not have a D here. So let me just take the liberty to put data as information. So now let's get started, and please unmute yourself and let me know what you think about analytics, how those keywords are related to it.
Sir, T belongs to technology.
Okay.
A for analyzing.
Okay. A for analyzing.
S for statistics.
Okay.
C for creativity.
Okay.
So N for normalization.
And you can have multiple words, so don't restrict yourself to the count of one. So if you have more ideas, please keep sharing.
Sir, N for numerical data.
Okay. You put it as numbers.
Numbers, okay. Yeah.
C for characters.
L for list.
Okay, so you are getting deep into the form of data. Okay.
S for string.
T for type.
Type of what?
Type of data.
Okay.
C for charts.
Charts. Okay.
A for algorithm.
Very good. Algorithms.
Aptitude.
Okay.
So T for transformation.
Right. Transformations.
L for language.
Yeah, this is a you mean transformation of data?
Yes, sir.
L for language. Okay.
C for collection.
Collection. What about Y?
A for analysis.
Yeah, that we've covered. And
Yearly data.
Yearly data. So see, that is just a frequency, and it could be anything, quarterly, monthly. So but it's the same. Let me just capture it for now. Okay, so using yesterday's data to predict for tomorrow.
So I for imputation.
Imputation. Okay.
I for index.
Investigation. So you have to investigate the problem. which is
Computation,
analyzed.
sir. C for computation.
Computation.
Yield and resistance of data. Resistance or resistance of data.
Sorry, I didn't get you.
Yield.
Yield.
Y for
Okay. Oh, okay. Very good.
yield
So,
and resistance or resistance of data.
Assistance. Sorry, I didn't get you.
Yield and resistance or resistance of data.
Okay. So see, you can also have yardsticks because you have to always measure your output.
So as for standardization.
Okay. So now you're getting into the techniques. All right.
S can also represent summary.
So few things that are missing, still missing, basically the industry knowledge, domain or context. So we should definitely add them. Industry experience or context.
Supervised learning.
Supervised learning. Okay. So I'll just capture it in learning. That will capture all kinds of learning. Supervised, unsupervised, reinforcement.
A for approaching.
Approach. Okay. And you may have heard a lot about
application.
A for application, and you may have heard a lot about AI, artificial intelligence.
L for library.
N for numpy.
Yeah, numbers are covered. L for library. And L for logical reasoning. That is super important.
Y for y-axis.
That is where. All right. Anything else? Last 1 minute.
Standard deviation.
Standard deviation. Okay. So see, these are all metrics.
I for intelligence. I for intelligence.
Okay. Intelligence.
Simulation.
Okay. So that is basically when you try to simulate the data, generate the data. I for
tests.
there should be impact, right? That we need to create.
And for
Basically, okay. All right. Anything else? Yeah.
I've just muted the person.
Okay. And okay, so let me take it over from here. So you also need to program, right? So someone mentioned about language. So coding is also there. You've already captured technology, statistics, impact, industry experience. So these are something which are essential components of analytics. And we'll go deeper into it. But the idea was to have some collective understanding of what we think about analytics as of today, right? So let me just switch the gears and move to the next one. So just a second. All right. So let's set the goal here. Let's get started and let's just set the goal first. So our goal today is to become a better version of who we are in the field of analytics as of today. So that is how we should think about this session. So let's say you are currently a beginner, then the objective will be to become better. We'll move towards becoming an expert. Then let's say we are an expert, then we'll move towards becoming a better expert. Basically handling data better, processing it in a better way, creating more impact. So all the things that we discussed a few minutes back. However, if you feel that we are master of analytics, I would suggest please refrain from that idea. There's no such thing. And if people believe you are, then let them believe. We need to move away from this track of thought. So whenever you feel that you have become a master of the entire stuff, please take a step back and see, is there something more to learn? And that's the point where you need to stop, because otherwise we'll stop learning. So with that goal in mind, let's move forward. Okay, so we talked about analytics. We looked at various keywords. Now, if you want to define it, the way to define it would be understanding patterns in data in a systematic way to make decisions. And all these words are very important. How basically the data. So if you have data, then that data can also be of multiple forms and shapes. It could be small data, big data. It could be, say, structured, unstructured. Within structured also, there are so many ways it can be available in form and shapes. For example, image, video, audio, text. So you have to process that data well, basically read it, understand it, and then create transformations on top of it. And the objective here is to understand patterns in that data, which means that you would be analyzing, investigating, trying to solve the problem which the stakeholders have in a systematic way, which means that the process should be defined in such a way that you can reproduce the results. Also, you should be able to code that in a form that you can leverage those analysis for other problem statements as well. So it should not be in an ad hoc or haphazard manner. Ultimately, the objective is to make decisions. So unless and until you're able to create the business impact, the analysis will not be of much use. So hence, we will need to be very clear what kind of decisions we are trying to make by doing the analysis. Now, those decisions could be of multiple types. Let's say someone tells you that my business is shrinking, I need to grow it, or my business is there, but I'm not able to retain the customers, their experience is deteriorating, or I have a lot of processes and I need to improve, because if I improve the processes, I will be able to reduce my cost. So overall profitability can go up by increasing your revenue or reducing the cost. Right? Similarly, there could be some regulatory requirements where you need to follow some regulatory requirements, otherwise you will end up paying the penalties. And that will be more like a loss mitigation rather than growing revenue. But that is also equally important for any business. So hence, we need to understand what kind of decisions are to be made before we start off our analysis. Then we need to see what kind of data is available to us. Then the third part would be to understand if this requires some deep dive analysis or reporting or predictions or leveraging the AI. So all those things that you need to decide based on your problem statement. So after defining data analytics, let's ask a very simple question to ourselves. What is A plus B square? And it seems pretty basic, but let's say this is being asked by a learner of, say, class 7th or 8th, right? And if you remember, right, the way we were taught about this formula, we used to mug it up. However, the question comes why, right? And this learner is, if asks you why, then the answer should be in such a way that the person understands. So the typical response that you get from the people is that it's a formula. It's given to us. We can't change it. The question, why is this a formula? Then there is a response that, okay, why don't you just try it yourself? Why don't you just put the values of A and B and validate yourself whether A plus B square is equal to A square plus B square plus 2AB or not? Again, the question comes, why will it get validated? The answer is like, it's a formula. But why? So this learner will keep on asking until and unless you explain why this A square plus B square plus 2AB is a derivation of A plus B whole square. Okay? So let's take a step back and try to generalize this. So as you may remember, we can always expand the expression. So A plus B into C plus D, if that is the general form, it's A times C plus D and B times C plus D. And that's how you can simply expand it. Right? And if you assume C is A and D is B, then you can prove that a plus b square is this. However, this is just a way of understanding it and convincing yourself that you understand a plus b whole square formula. But if you need to explain it to that kid, then you need to go deeper. You need to find out some creative ways of explaining it. Right? And let's say this, we have a square here with a side a plus b. And if you now divide it into 4 parts, where you have 2 squares and 2 rectangles, right? Where these are the 2 squares that are highlighted in orange and the 2 rectangles in white. Now, if you see, we can just simply put the area here, a square, ab, and b square. And that is very easy to explain why this a plus b whole square is equal to this. Right? The idea here is to also go to that level where we understand the basics and we acquire that capability to explain the things to others. So we need to go to that level of understanding before we start claiming that we can solve problems for others. So of course, this was not analytics, but there are 2 lessons to learn from here. And I would say, yeah, the thing that I just mentioned, instead of saying that I know things because it's a given rule, we have to go to the level where we say that I understand because I understand the derivation. And the part which is required here to move yourself from I know to I understand stage is your curiosity and logical reasoning. Right? And I believe this group is anyway very, very curious, and hence you are spending time and investing time in yourself to understand more about data analytics today. The other part here is then when you go to that level where you try to explain things to others, then you need to tell them that, okay, this is how you visualize, and you need to bring some creativity. You need to communicate your thoughts well. So that is another skill that you need to keep in mind when you get into data analytics. Of course, this mathematical expression was not an example of analytics, but these are the 2 key lessons that we can learn from this simple example. We need to be curious enough to keep questioning why. We need to apply our logics to understand the derivation to the nth level, and we need to be creative and good communicators to explain our findings to others. Right? So these are the 2 key lessons before we get deeper into it today. Now, if we move to our next page, here we see that we have 5 kinds of analytics forms, or you can say types of analytics. Descriptive analytics analyzes and tries to give you the reasoning, understand what happened. Right? So when I say my customer base is shrinking, I need to understand whether it's actually customer base problem, or it's because my product quality is not good. It's because my customer care is not solving the problem well, or it's because my product is too pricey. So all those things we need to analyze and then start reporting. So here the action for any analyst is creating the report first, and then try to understand what happened. And if you look at the X and Y axis here, so as you see here, the X axis is business value and the Y axis measures the complexity. So as we move from descriptive to diagnostic analytics, the business value and complexity both increase. This does not mean the people who are into descriptive analytics are not valuable. This basically means the outcome that you're going to deliver will have more value to the organizations that you are solving this problem for. So hence you need to also understand, are you answering the right question? If they're asking you what happened and you are trying to solve what will happen tomorrow, that's not the right match. The next part comes in, like, why did it happen? Whatever happened, but why did it happen? And hence you need to do some investigation, and that is called diagnostic analytics. Here, the action item for us is to find the root cause of what happened. The third part is what will happen tomorrow. So what has happened, but I need to also understand what is going to be the future like. And hence you need to predict, you need to build some statistical model or strategy or something futuristic. The next part is, okay, I understand, I have the mathematical numbers, I have the probabilities or the estimated values for all of my customer base. when you are selling one thing, you can probably bundle it with the other, and that will be a better deal. Or you need to do something more about retention of customers through measures where you can call up customers and try to make them feel better in terms of addressing their problems faster. Then the other part comes in, whatever I'm going to do with them has to be more human-like, and because we apply a lot of machine learning while solving the problems, but at times it becomes very difficult to interact with the people when you have to communicate your outputs. So here, a typical example would be, say, a Google Assistant or Apple's Siri, or let's say, Microsoft Cortana. So these are virtual assistants, and when they provide you service, and if they provide a wrong answer to your question, then your experience deteriorates. So you need to leverage AI and ensure that whatever final outcome you're providing to your customer is human-like. So that is more about the cognitive analytics. Now we have looked at what actions we need to take across different analytics spectrum. However, there is an opportunity also associated with each of them. When we are creating the report for descriptive analytics, we have an opportunity to fully automate it. If you automate it, then you will be able to spend more time in analyzing it. And there are a bunch of tools that exist, the languages, the processes through which you can fully automate all these reports. Many times customers say that, okay, I have the report with me, can you also add some commentary to it? Right? And there are ways to even now start automating commentary to some extent. Okay, so if we get into diagnostic analytics, and as I said, you also need to explain your output, and hence visualization is going to play a key role. So whatever the root causes you find, you also need to communicate, and the opportunity here is to visualize that data and also show it in that form which is easily consumable by your customers. When you move to predictive analytics and you are building a statistical model, the opportunity lies in improving the accuracy. There will always be an expectation, can you do better? Can you use more data? Can you use a more sophisticated algorithm? But if you overdo it, then the problem will be there that I cannot explain it, I cannot use it, I cannot implement it. So you will need to create that balance between your output and implementation. So here the opportunity is to keep on improving the accuracy. At the same time, the trade-off will be the interpretation and implementation. So you have to keep that in mind. Now, if we talk about prescriptive analytics, where we are recommending actions to the business, here, unless and until you quantify the business impact, people will not value it. Here, the opportunity is to quantify whatever outcome you are providing. Is there a way you can convert it into some dollar values? Can you say that, okay, if you take this action, you're going to save this amount of money? And hence, that will also be a reason why any industry expert would be offering you that project where you can consult, you can get the money. Right? The next part is cognitive analytics, where you are leveraging AI. Here, the opportunity is to keep on improving your customer experience. Right? So it's as good as enhancing accuracy in predictive analytics. Here, the focus should be more about how you're interacting with humans, because here you're using an AI and you need to ensure that it is mimicking the human mind. Again, many times people debate that AI is going to take a hit on the jobs, and that is a different school of thought. However, the objective here is to improve your customer experience, not to take anyone's job. Okay, so with this base in mind, let's keep moving. Now let's look at the work streams that we have, right? When we talk about data analytics. So there are three key work streams, as you can see on the screen: technology, statistics, and domain. Right? I would say these are three different gates to enter into the field of analytics. And if you do not have anything, any of them, that is also fine. You know where to get started. Right? So let's say you are a statistical expert and you have no idea about how to code it. or how to use the big data platforms, or how to use cloud computing, then you need to diversify your skill set and start getting into the technology part of it. But you, at the same time, you need to also understand the domain, the key objectives of the business, what is going to work, what is not going to work. For example, if we talk about approving the loans for someone, then you have to also ensure that you follow all the rules. You do not differentiate people based on gender or let's say ethnicity or something which is not acceptable. So that domain knowledge is also important, and you cannot just go on number crunching and provide any solution which is not going to get implemented eventually. So hence domain is super important. Let's say you come from industry experience of say 10 years, 20 years, and you do not have any idea of statistics or technology, then you know that you have the information with you, but you don't know how to use it. That is the reason why you need to upskill yourself, get to know a little bit more about technology and statistics. And same goes with the technology. If you are a hardcore coder or a data engineer and you have no idea about how statistics runs or what are the different tests you need to do, what is going to be useful from the business standpoint, then you will not be able to progress further. So the idea is to keep on moving towards the center where you can have information or understanding of all three work streams eventually. So that is what we call as analytics leader or an expert. Another part here to keep in mind, if you are in like you excel in one of these work streams, you also have the advantage of improving upon one of these parts. So let's say you are a statistician, then you have an edge because you can always provide more accurate results. And what you need to keep in mind is that the results should be, or the outcome should be practical, implementable, and efficient. With technology in place, you can make your solution more efficient. And if you are a domain expert, you will talk more about the practicality of the solution. So as you can understand, all these three work streams, or the experts in these three work streams, bring a lot of value because of their respective background and understanding. So with the right mix of all these components, eventually we should be able to do well in the field of data analytics. That is what my message is on this page.
Excuse me, sir.
Yeah.
Could you explain what domain actually means?
Okay, so domain means industry. So let's say you are part of insurance industry. So you need to know how to charge the premium for those insurance policies, right? And if you, let's say, part of a banking industry, then you would be more into the.
Thank you, sir.
Okay. Any other questions so far?
So for like being an analytics leader, so we should be like have a proficiency in one of the three components or all the three components like domain, technology, or statistics. And
good question. So of course the objective should be towards gaining proficiency in every I mean, these are the building blocks. That is what I would say. So you need to have a proficiency in all of them eventually. But let's say you are more into technology and less into domain studies, you just need to know that I need to acquire these skills as well, so that when you have the right combination, you will be able to make better decisions. And it's always a teamwork, right? When you start a project, when you do a project, you always have a team of diverse backgrounds, and then those specific individuals should be able to take care of their respective areas. Does that answer your question?
yes, sir. Yeah. Thank you, sir. Thank you so much.
Okay. Now let's go deeper into this, like how statistics can make us a better data analyst. And as I mentioned earlier, our objective is not to become master. Our objective is to become better than what we are today. So let's say we have a situation where the question is statistically significant. We come across this word many a times. This thing, whether things are statistically significant or not. So think of it as a bank CRO's point of view, who is asking you, I want to understand how much money the credit card holders are going to pay back. Which means that this particular CRO has a bunch of credit card holders as a customer base, and there's a lot of outstanding balance on their books, and she wants to understand how much money I'm actually going to get back. Not everyone is going to pay back everything. You remember we had a learner on the first page, and that probably that learner has grown into this expert analyst now, and she's saying that I have developed a payment projection model for you. Basically, it essentially projects or estimates what payments you can expect from your customers in future. The question comes, okay, I have a solution, but I do not understand when you say credit score in the equation is statistically significant. Right? So that is the reason, I mean, the CRO is confused, or the statistician needs to help. Right? Again, we need to take a step back and try to understand the basics. So in the utopian world where things are all idealistic, but not realistic, as in they do not exist, you would say estimated payment on a credit card bill will be equivalent to whatever is due. So if someone is having a bill of say $1,000, and you anticipate that and that $1,000 will get paid, and that too for all customers in your on your books, then it will be a Herculean assumption. That's not true. Right? So in reality, what happens is it is of this shape, beta naught plus beta 1 into past due amount, where beta naught is not equal to 0 and beta 1 is not equal to 1. Right? So this is how you can put it. However, I mean, if you also talk about an example, say 250 plus 95% of my past due amount, this could be an example. So beta naught and beta 1 are just coefficients of this equation. So this equation is more realistic than what we had in on the first row. Now, if you talk about a more real model, probably it will have more variables. It will not be just dependent on what was due, because past due amount is only telling you what amount you can possibly expect. It will be in the ballpark of what was due. So if there was a bill of $1,000, you would expect everyone to pay back close to $1,000. It cannot be 2,000. So definitely this is important, but there are other variables as well, like how many days have passed since that amount was due, or what was the credit score of that customer. So you know about, say, CIBIL score that we have in India, that gives you the credit worthiness of the customer. So if you keep paying back your bills on time, you keep on accumulating a better credit score. And days past due is basically, let's say the bill was due on 30th of the month, and you have not paid, say, even for next 7 days, then the days past due will be 7. So it's a number of days that have been passed since the due date was there. So this is also an important variable that plays a role. And there actually are many more. So of course, for the sake of simplicity, I'm just sharing these 3 variables. However, there are going to be many, many more variables, characteristics that are going to play a role in estimating the payment that you can expect from your customers. Now, another part to keep in mind here is that past due amount would have a positive coefficient, while the days past due is going to have a negative coefficient. So that is called a business hypothesis. So more days you pass, you see getting passed after the due date, less likely you're going to get the payment back. Also, people make partial payments. So hence, this estimated payment may not be equivalent to your past due amount. Then there's a concept of minimum due payment. People just pay the minimum due and revolve the balance. So with all those things in mind, we know that there are going to be multiple attributes that are going to decide on my estimated payment. And that's how I'm going to provide an answer to the CRO, the Chief Risk Officer. So this is just an example, let's say 15 plus 0.22, and these are just coefficients that we're talking about. Now, if you look at the data, right, so the past due amount, days past due credit score, you can also try to make some sense out of it by just looking at these numbers. The past due amount is whatever it is, but so only 15 days have passed since the due date, and the credit score is just 500. So typically the credit score range would be say somewhere from 250 to 900, right? And the higher the credit score, better the customer. So that is something where the domain knowledge is required, the industry knowledge is required. And then you can say that this customer is a subprime customer at an early delinquency stage because not much time has passed since the due date. However, the second case is where the credit score is higher. It's pretty good score, and this is super prime customer, again at an early delinquency stage. And the next one is even better customer in terms of credit score. However, only 2 days have passed. Probably is a sloppy payer, which means that this customer has just forgotten to pay, and most likely will pay next couple of days after sending some reminders. And this is also possible that this customer does not pay even after having this score, and hence there cannot be a perfect match and perfect equation to solve their problem. Lastly, we have a customer where the credit score is again low and the number of days passes is also very high. So it's a very, very bad customer because the super prime customer at late delinquency stage, probably all these $1,500 will go away and he will not pay anything to the CRO, to the bank. So keeping these things in mind, now we know that these variables are important. And I mean, we need to also prove to the business stakeholder that why they should be there in the equation. So the way to put it is, let me check whether this equation holds true. So this credit score is statistically significant or not. So it is as good as asking whether this beta 3 is significantly different from 0 or not. So if this beta 3 is, let's say, is equal to 0 or close to 0, then credit score has no value. I mean, this variable will have no value in this equation. So hence, when you say that this particular variable is statistically significant, you are essentially testing whether this coefficient is significantly different from 0 or not. So that is one first step that we need to keep in mind. Now we can define our null and alternate hypothesis. So if my null hypothesis is beta 3 is equal to 0, my alternate hypothesis is going to be beta 3 is not equal to 0. And since you know that beta 3 is going to be positive because it's a credit score, it should have a positive impact on the payments. You can also try beta 3 greater than 0. That will be a one-tail test, and this is a two-tail test. Right. Now, then you can compute the t statistic by using this formula beta 3 minus the value of the beta for which you're testing, which is 0, and the standard error of beta 3. Right. The part here is that you need to understand this concept before simply saying that this variable was statistically significant. And there are multiple ways to address it. You can always reach out to the statistician in your team and say that, okay, whether this person has confirmed or not, or you can also deep dive into it yourself and then try to explain it to your client or the customer. Right? But in any case, you should not be giving the answer that this is what it is. This is what the software has given to me. The p-value is less than 0.05 and hence it is statistically significant. So try to avoid those kind of responses to your customers. It just shows that you do not know the full thing. So that is the key message here, that we have to understand our basics and then try to answer or provide the responses to the stakeholders and solve their problems. That is going to make us a little bit better than what we are today. So let's talk about another example. Let's say the question comes, why MAPE, why RMSE? And these are just some metrics of error, mean absolute percentage error and root mean square error. That's also a very standard question that you can see coming all the time. So let's take an example of a retail chain chief financial officer, and that person wants to forecast quarterly profits. So every quarter going forward, what are going to be my profits? Is this an estimation he needs? And his question is, how do I evaluate the accuracy of these predictions? So whatever prediction he gets from his team, how can he make sure that those predictions are in line with actuals? That is the question. Okay. The answer is, you may use some error metric, actual minus predicted. Basically, you can check how your predictions are off your actuals, and then you can take a call on whether these predictions are accurate or not. But the confusion is that he sees a bunch of those metrics: mean error, mean absolute percentage error, mean squared error, the root mean squared error, and actually many more. So then again, the confusion comes in. Like how do I pick the right metric? Again, you being an expert analyst, you need to solve this problem. Right? So let's start from very basics here. Let's say these are the actuals: 90, 95, 105, and 110 for the 4 quarters. And the predictions are, let's say, for the sake of simplicity, prediction is $100,000 for every quarter. So all these numbers are in $1,000. If you take the sum, you get 400 in both the cases. The mean value is 100 in both the cases. And you look at the error, of course, basically you're just checking A minus B, actual minus predicted, and you're getting the error metric. If you take the mean of this error, of course, it comes out to be 0. And as you may all understand, this does not make any sense because the errors are getting offset. So the interpretation here is at annual level, I'm predicting everything fine. My predictions are accurate. $400,000 is what I was having in actual, and $400,000 is what I'm predicting. But when I break it down by quarters, my predictions are not that great. So the way to look at it is that let's take the absolute value of it and see what is the error number here. 10, 5, 5, and 10. So the total error is 30. If I take the mean, it comes out to be 7.5. The mean absolute error is actually 7.5. When we take the square, then this is another thing that we need to keep in mind. We have taken care of the negative values by taking the absolute. However, if we take the square, basically this seems like this is just a formula, root mean square error formula, but we need to understand the meaning of it. The meaning is, if I am having higher error, let's say 10 compared to 5, I need to give more weightage, or I need to penalize this more, and hence I'm multiplying 10 by 10 itself and 5 by 5 itself. So this way you understand why RMAC is slightly better than mean absolute error, because this is giving penalty to all those errors that you're having here. So the magnitude of error is getting the penalty by its own weight. So this gives you RMSE. Now the other question comes in, okay, what does this mean, 7.91? Can I say that my error since 7.91 is low or high? I don't know. I have to also look at the other metric, which is absolute percentage error. Here what I'm doing is that I'm just using the base. This absolute value is now converted into a ratio. So A minus P divided by A, right? And of course the mod of it, so that you take care of the signs. So that is why the absolute value. So there you see that the error that you have is 7.6%. Now it has a lot of meaning. You can say that my predictions are off by 7.6%. That is how I would interpret, rather than saying that my predictions are 100% accurate with what I saw in the mean error. The other part that we need to keep in mind, the scale of the data may change, right? So here for now talking about values in $1,000, but the same data when gets converted into dollars. So everything gets multiplied here by 1,000, right? The actual as well as predicted. The thing that is not changing is mean error, right? And the mean absolute percentage error. However, your mean absolute error and root mean square error, they are getting changed because of this scaling factor, which means that these are not scale independent. So this is also one of the reasons why you need to keep in mind a metric like mean absolute percentage error, which remains same irrespective of the scale of the data. Right? Now, if you also now start comparing these metrics, if you compare mean error with mean absolute error, right? Mean error is offsetting all your positives and negatives and is not giving you the full picture. In this simple example, they are completely offsetting, and hence you're getting 0. And probably you will understand that my error is not 0, there's something wrong. But in reality, you will get some error when the values will be of different magnitude. But that will be an understatement of the error, because the negative errors will get offset by the positive ones. Hence, mean error is not a metric to look at for sure. Mean absolute error is definitely better. But when we compare mean absolute error and RMSE, we know that RMSE is giving more penalty to error by assigning the weight as error itself. And hence RMSE is better than mean absolute error. And there you see, here you're getting an error of 7.5, but it is giving a slightly more stringent way of looking at your predictions. The error is higher here because of the weights assigned. But when we compare now RMSE and MAPE, here we have a kind of trade-off. So RMSE is definitely more stringent because it is giving the weight, the square, by taking square, it's giving the weight. But it has a drawback that it is scale dependent, as we saw here. So when to use RMSE? So when you are building two models on the same data, you can use RMSE to compare which is better. The lower RMSE, the better it is. However, when you are solving two different problems, working on two different data sets, then you cannot compare RMSE of one data set with the other. That is one point we need to keep in mind. And then something like a MAPE will be more handy. And here you can say 7.6% here, or say 10% somewhere else. 10% is bad and worse, or MAPE of 7.6% is better. So in both are usable, but with some caution in mind. So again, this is just one concept, and there are hundreds and thousands of such concepts that exist in statistics. I just wanted to highlight the point. When people ask you question, just do one thing, just try to research a bit on it and see if you can provide a better answer rather than saying it is given. I'll take a quick pause here and see if you have any questions so far.
So Varun, Nitin has a question. He says that minimum due amount and partial payment considered as variable while drawing these conclusions.
Yes. So you're talking about the previous problem? Yes.
Yes.
So in reality, many such things are being taken into account. In fact, there are so many characteristics of the customer. How much amount he has paid in the past, a number of times he missed his payments in the past. All those things are to be kept in mind while you build the equation. Okay. So here, my focus was not on looking at the variables, but to give you a concept of how to look at the statistical significance of them. Okay.
Audience, do you have any questions? Varun, I guess we can move ahead now.
Okay, sure.
Yeah.
Okay, now let's move to the next part, how domain knowledge makes us a better data analyst, right? And again, for example, I had to pick one. I have picked fraud as one of the domains that I can talk about today. So let's understand what are the different types of credit card fraud. So, and I've taken credit card as an example because credit card is something relatable to masses. Right? All of us have credit or debit cards and we understand it very easily. So here, see, there are three kinds of fraud that happen. The first party, second party, and third party. The first party fraud happens when the customer himself is the reason behind it. Right? And let's understand how. Okay, so there could be a straight roller case. Basically, it means that you have taken the loan, but you're not paying the payments. So making the payments, for example, let's say it's an installment loan where you have, or it's a credit card. Let's in this case, so talk about credit card only. You are not paying any due amount, and you're defaulting every month. So in that situation, eventually your the amount will get written off, and it will be a bad debt for the bank. So that's a straight roller case where you keep on missing out your credit card payments month over month. And after say 6-7 months, you get into the bad debt category. The second kind of fraud that we see here is a payment fraud, where there's a, for example, there is a facility of overdraft or over limit. So every credit card comes with a limit till when you can make the use the credit. So let's say your limit is 1 lakh rupee and you are overusing it to 1,10,000. So there will be probably some extra cushion that the bank may provide to you. But if you overuse it and purposely and you keep doing it every time, then it's also kind of a fraud, which is not acceptable. Check kiting is another example where you write a check of more than what you have in your account. Right? So that's another kind of a payment fraud that we typically see. False dispute claims are ones when you let's say swipe a transaction and then you raise the claim that I did not make that transaction, and then it gets into the discussion with the bank whether this transaction you made or someone else made, and it actually may be possible that the customer himself made, but he's just making it up. That false claim is also an example of first fraud. The third type of fraud here is synthetic identity. Here, when you apply for credit card without using the real identity, that will be synthetic identity fraud, and that is again driven by the customer. The second party fraud, however, is something which is related to first party in a way. Here, someone is sharing the personal information with the family members or friends, and they are making these kind of fraudulent activities on behalf of the customer. The third party fraud is very common. It happens when an unknown individual commits the fraud. So let's say someone takes over the account completely over phone or through online channel. Right? So if you log into your bank account and you see it's actually not working, someone has hacked it or something like that has happened. So those kind of things come under account takeover. Then transaction fraud is very, very common. So you see, right, when you swipe the card, you get whether you get a notification whether the transaction gets accepted or declined. So you see many times the cards get lost or stolen. There are some counterfeit cards that are created. So all those come under transaction fraud. The third one is the application fraud here. Here, basically someone is stealing your identity and applying for credit on your behalf. So the difference between synthetic identity and application fraud is that in synthetic identity, the customer himself is fraudulent, while in case of application fraud, someone is stealing your identity and applying on your behalf, mimicking you. So this is the background of different kinds of fraud that we see on the credit card side. So with this background and domain knowledge, let's go deeper into the transaction fraud and what are the key challenges with it. So first of all, this is huge. Credit card transaction data is huge in terms of the volume as well as volume across the globe. And it is being said that there's going to be a significant increase also due to shift in to online channel triggered by COVID. So as things are becoming more and more convenient for the customers, they can use more online channels than before. It is also exposing them to more fraud. One of the key challenges here is the imbalance classes. So you see, when you have say millions of transactions for a bank, only few hundreds of thousands will be fraudulent. So the fraud event rate is going to be extremely low. Typically, it's lower than 1%, which means that even when you just approve all transactions that come your way, you're going to achieve 99% of accuracy. Which means that if you're approving all transactions, the fraudulent transactions will also get approved, and all legitimate transactions will anyway get approved. So hence, there will be a misclassification only for the fraudulent ones. So 99% accuracy will be achieved. In any other scenario, if you say that my model is 99% accurate, it's actually too good to be true. 99% is not enough. So it is a very big problem. And the way to solve for it is doing oversampling or you do undersampling of non-events. The second key challenge that we typically see in this kind of a problem statement is the classification trade-off. So here, if you overdo it, let's say you keep on declining every single transaction here and there, then the customer experience will get impacted. Right? You go and you swipe your card, and let's say you travel a few miles away, and then you see that, okay, my transaction is getting declined because of the location trigger. You may not like it, and you may actually switch to a different credit card issuer. So the banks also need to keep in mind that how they maintain the customer experience. So there's a trade-off. If they do not decline those transactions, then there's a chance that the money will be lost. So that is why they need to maintain the balance. The second important part here is, even when we correctly classify the fraudulent transactions to a large extent, we need to prioritize them, those transactions which are more valuable in terms of total amount. So if you capture a $1 transaction versus a $1,000 transaction, definitely $1,000 transaction will be more important for the bank. So hence, there will be some play of transaction amount into this. You need to do prioritization correctly. The third important factor or the challenge is the dynamic patterns in this particular industry. So the fraudsters keep on inventing new channels, and there are a lot of new loopholes that they keep on working on. So as regulators make it difficult for them, fraudsters also keep on inventing. And hence, it's always very difficult to understand what's going to happen next. Other related problem is this, that since they keep on inventing, it's very difficult to understand the past patterns. So as we learned earlier also, that analytics is all about understanding the patterns in data from yesterday and predicting it for future. So here, if the patterns are going to change, your models are not going to work that well. That is why the shelf life of fraud models is typically lower than other models. The other part here is the conventional methods like amount and location are not going to work that well. So if the transaction amount is too high, that is a typical way to send an alert to a customer that probably your transaction is fraudulent and it should get declined. Or if you are seeing a significant shift in the coordinates of the transaction based on location, so that is also something which raises the alert. But these are very conventional methods, and as fraudsters have also evolved, the banks or the credit card issuers also need to do something more than the existing methodologies. The fourth important factor here is the exogenous drivers, which means that there are some external factors which come into play. As we understood, this is third-party fraud. Here, the fraudulent person is not known. It's not your customer that you can just look at the behavior of the customer across different trades. You have to deal with those people who are gaming the system and who are unknown to you. Secondly, there are certain things like I mentioned before, COVID-19 has come, things have changed significantly. There's more digitization, which is also important for better customer experience. But these external factors also impact this industry a lot. Then the fifth important factor here is the real-time decisions that you need to make. So there's always a trade-off between the sophistication or elegance of a solution and its deployment. So if you make your solution more and more complicated by doing, say, 100 ensembles, probably you will be able to you can make the solution more accurate and you can capture every fraud, but then it may not be possible to implement it in few seconds. So the approval or decline decision that a bank needs to make has to be very, very quick. You cannot wait for a minute for your transaction to get approved or declined. So with these factors in mind, we understand that the challenges are too many, and the idea is to understand the domain, because we're talking about how domain can make us a better analyst. So let's now move to the problem here. So this is a head of fraud department. This guy is saying that I don't have data. My fraud detection strategy is currently based on the value of the transaction. So if, let's say, someone is spending $100 versus someone is spending, say, $50,000, you will probably decline $50,000 transaction because it's of too high amount. But when you do that, the false positive rate is also very high, which means that you are unnecessarily flagging some transactions as fraudulent when they're actually not. So it is going to impact your customer experience, and hence you have to solve for it. So the expert analyst would say, why don't you use more information? And this guy is saying that we don't have anything else. There's no meaningful data. Just a couple of fields like merchant ID and timestamp. That's it. I don't have anything else to make any decision here. So the answer is yes, you have it actually. You don't know, but let me help. So you need to keep in mind he has merchant ID and the timestamp as additional variable apart from your transaction amount, and that's all he has. So one insight that this analyst can provide, that based on the merchant ID, the merchant category can be decided. And the merchant category essentially means the type of spend. So for example, if you are spending on petrol, gas, right, versus you're spending grocery, personal care, dining, health, right? So these are different kind of categories that you see here. So basis the merchant ID, you can understand where that spend is happening. And then instead of applying logic on the transaction amount itself, you will see whether it makes sense to create those outliers specific to the category. What I mean to say here is, if you see here we see something close to $2,000 is what someone is spending on travel. So if you go and book your tickets for international flight, the outlier here is $2,000 or $2,100 versus if you are making a transaction on a gas station, right? And then at gas station you see you're just making a transaction of close to say $100 at max. So here $100 is an outlier, while here 2,000. Outlier definition also should change by the type of merchant. And you need to remember the guiding principle in detecting fraud is to capture the suspicious activities. So if that is the key objective, that we need to identify or preempt those suspicious activities and then decline the transaction, we have to be a little bit more logical rather than putting it on just the amount. So here the play is we have to cross tab amount with the category, merchant category, and then create an outlier cutoffs. The second insight that you can generate based on the timestamp, like I said that I just have a system generated timestamp, but if you analyze it further, you'll probably realize that the fraudulent transactions are more after 10 p.m. and between 3 or 4 a.m. Right? So here the fraud rate is much higher compared to what we see during the rest of the day. Hence, time of the day can be one of the variables that you can create and then use it in your model. So off-peak hours show significantly high fraud rate. That is how you're going to explain it to the business stakeholder. The third important insight here is based on the timestamp again, you can also put the number of transactions, the frequency of transactions as one of the variables. So whatever transaction happened, you just take 30-minute back view. And within those 30 minutes, if you saw no transaction, one transaction, two or more than two transactions, you will see that, okay, when there are more than two transactions in the last 30 minutes, the fraud rate is as high as 20%. While when you have a case where there is no transaction in last 24 hours, the fraud rate is very low. So again, there's some suspicious activity happening. There's a spike in the number of transactions, and hence you need to address them and you need to immediately decline the transaction. By the way, as I mentioned, the fraudsters keep on inventing new ways. So based on my experience, I've seen that earlier there used to be a lot more frauds on high amount, but now things have changed. People have become smarter, and they, let's say, keep on making $10 transaction every now and then and keep on using that money. Because if they make a $1,000 transaction in one go, it will get caught. So since these patterns are very dynamic in nature, You cannot have one single rule to address all problems. So such kind of creative variable creation helps. You need to look at the frequency of transaction and not just the amount. That's another takeaway. And I think with this kind of variables, if you create a model, that will solve the false positive rate problem also for that individual. Any questions so far on this particular case study? How to use your domain knowledge to become a better data analyst?
Hi Varun, I have one question. Like as you told, we are just wanted to reduce the false positive. But
Yes.
what is the threshold for that? Because if suppose, as you told, that people are also becoming more smart, like fraudulent, and they are going to take the small amount in a multiple chunk, multiple time stump.
Correct.
So how exactly we are working to reduce the false positive?
Good question. So see, fraud is a very typical problem which has very different way of looking at the metrics. Right? In a particular classification problem, you would see simple misclassification or accuracy metric, confusion metrics. Those are enough. But in case of fraudulent transaction detection, you have to look at a different way of looking at the model performance. So what we typically do is we look at this top 1% population. Population as in the top 1% of your total transactions, and then see what is our hit rate, how many have been correctly captured, and what is the value of total fraud that you have captured. So fraud anyway will get reported, right, sooner or later. So you will get to know whether it was fraudulent or not. So you have your target variable in place. All you need to do is to ensure that you capture the right kind of transactions in terms of frequency as well as in terms of value in those top 1% that you're going to decline. You cannot go and decline 5%, 10% transactions because they are huge. There are millions of transactions at times. If you decline 5% of them, most of the customers will actually stop using your card. So I hope that answers your question, that we need to define that threshold first, 1%, 0.5%, and then try to maximize the total fraud capture rate.
Okay. And we can keep adding the learning which we are getting, right? Because
exactly. So this is something which is also getting into self-learning mode. So more transactions you identify as fraudulent, the model gets trained accordingly.
Yeah. So in this COVID situation, did you find any sort of different trend is going on, and the different sort of fraudulent is happening, or the type of fraudulent is still same before COVID? Like
the fraud, many activities have got changed. In fact, first of all, the online transactions have increased so much. So the thing that used to be like this 10%, it has got flipped. Now 90% of them are online, and that is of one particular portfolio I'm talking about. And then within that, the way people are doing fraud is also changing. It's not just about time of the day anymore. It's a combination of different things. So if you see someone is making a small amount of transaction, but on a category which has never been used before, that is also a way to flag it and see whether it is worth approving or declining. So there are different ways people are making fraud, but then there are very well established fraud rules. In fact, now the banks have also started making a dedicated team for improving customer experience. And we have too many strategies, and we need to simplify them. So it's not just about accuracy; it's also about also not declining those transactions which are actual, which are real.
Correct. Thank you so much.
Okay. Any other question? All right. Let's keep moving then. So now let's see how technology makes us a better data analyst. So here, first of all, technology is something which is everywhere. So if you start from data itself, you will see there are a lot of discussion, and this has been for quite some time now. a bunch of big data technologies that exist. If you're not able to even read your data, how would you process it, right? So technology is going to be applied at the start of it. Then when you develop your solution, and as you just mentioned about auto learning of the models, auto ML is also something which is being talked about a lot. Is there a way I can automate the development of models, keeping in mind that the human subjectivity needs to be there? It should not be that automated that I get some spurious output which I cannot implement. So hence, auto ML is a very high responsibility for someone who's taking it up. If you're blindly for doing it, then the result will also not be usable. The third important aspect of the problem solving path is deployment of that solution. And there the technology is moving towards cloud deployment. Everything is now getting deployed on cloud. People are moving away from on-prem, where they have a bunch of servers and a lot of cost, very high computation requirements. So those all of them are moving away from on-prem solutions to cloud deployment. And it's not that everyone is moving, but a bunch of people doing that, and hence there's a trend towards it. So we need to keep in mind that whatever these new technologies are there in the market, we have to keep upskilling ourselves and try to get hold of what is happening around us. So let's say if you are a data engineer and you are an expert in big data technology, you probably also need to start looking at what the solution developers are doing these days. And if you are more into data science and you develop very sophisticated ML solutions and you have no idea how they get implemented in cloud, then also you're lagging behind. So keeping all these things in mind, we need to up our game, keep adapting to the technology all the time. Now let's say we have a situation where this person is saying I have a lot of data. The earlier one was saying I don't have data, but this one guy is saying I have data. In fact, a lot of it, but I don't have time. So I'm looking for a speed to market solution for cross-selling our insurance product. So what it essentially means is that I have some product, some insurance product in hand, and I want to sell another product to the same customer, and I need it really, really fast. So the expert analyst says, why speed to market? What about speed to value? The speed to value basically means that it's not only going to be agile, but also very valuable in terms of profitability to you, because the solution is going to be more accurate and high performing. So the question then becomes, okay, do you mean that it is going to be agile as well as a solid performing solution? And yes, the answer is yes, it is going to be that way because I am going to leverage the technology. Now, before moving to the next page, let me set the context. So, and it's a real example that I have faced. On one of the projects, we keep on getting a lot of variables every now and then. And the idea was to identify those interactions which can work better and improve the model. So if you do it manually, right, if you interact one variable with the other, you have to check many things, whether the business sense is there or not, whether when I multiply the two variables, they become meaningful, the correlations do not become counterintuitive, right? So if you're multiplying, say, A with B, and A has positive correlation and B has negative correlation, what should be the resultant correlation of A cross B? If both have positive correlation and the resultant correlation after A cross B becomes negative, then how would I explain? So there are so many things when you look at interactions. And if you don't look at them, then the model will not improve. So you need more features also. So there the solution was to automate it to a large extent. This is not an example of model development, but feature engineering. So here the idea was to create as many combinations of interactions as possible, basically using the combination formula, right? Where you say that, okay, if I have say 100 variables, so it will be C104. So then I will be creating all possible two-way, three-way, four-way combinations. You don't want to do something which is an overkill. So there you need to also come up with the right variable filtering process, right? Writing a code to automate this kind of super interactions is still possible and easy. However, the difficult part is to keep on reducing those variables to a meaningful set, which can be utilized for building a model further. And here we have an example. When we had 20 raw variables, we used this algorithm and exploded the data set with 6175 super interactions. Now, something where we had only 20 variables and we were finding it difficult to analyze. If you have 6175 super interactions, how would you analyze them? So there's also a need to filter them automatically, and so that you can see a smaller set of variables to further analyze. The very first step is to remove the redundant ones, right? Where you remove all those variables which have single unique value after this interaction. The next step is to look at whether their signs make sense. One variable is positive, other is negative, the combination is something else. So you have to ensure that signs match. And those variables that are not matching their signs, then probably need to drop them. The other part here is that since you're doing it on one data set, let's say your trained data set, the results may be overfitting. It may not work on your test data set. And hence you need to see whether there is a significant change in the correlation across train or test, or whether the correlations are stable. You need to remove those variables that are significantly changing their correlation on test data set. And these cutoffs are all subjective. It could be 5% or 6%, 10%. You can decide this is the requirement. Then the next part here is you can remove all those variables that are not contributing much. So let's say a single variable A has a correlation of 10%, while variable B has a correlation of 12%. And when you multiply both of them, you get 12.5. Then it's not worth complicating that variable so much that you just get a 0.5 percentage point higher correlation after multiplying the two variables. So in that situation, you need to identify those variables that have lower incremental value and remove them from a data set. Another important part here is once you go with this all combinations, some like one variable will come there many times, and you will see your variables and your newly created interactions will be highly correlated with each other. So then you need to take care of those variables as well, which are having very high correlation with themselves. So we dropped highly correlated variable, and then finally we were left with 60 powerful features that were analyzed further, and the model was improved. Of course, here also you cannot use all 60, and you need to pick and choose depending on what value they're adding. But the idea here is that if you know you have access to that technology to code things yourself, or even use already written codes, you will be able to add a lot of value to any existing project which is being done in a traditional way. So this is just one example of how you can use technology and become better in terms of your throughput. Any questions on this one?
No, sir. Clear, sir.
Hi, Varun. Can you please repeat the second point, counterintuitive one? So, like, I have always known, read multiple times that we always check the the relation between x and y, also between x1 and y1. If there is much correlation between x1 and x2, we do something about it. And also there should be some relation between x and y. But how it is, the second step is different from these 2 points. I did not get it.
Okay, so we are talking about interactions, right? So we are talking about a variable called C, which is A into B. So if your A, so let's say A is, just to keep it simple, let's say there are two variables x1 and x2, and you're creating a variable called x3. So in this x3 is multiplication of x1 and x2. Okay, that is the structure. Now if your x1 is having positive correlation with y and x2 is having negative correlation with y, right? The combination of the two, which is x3, may have anything, may have a positive or a negative correlation. Even when your x1 and x2 are having positive correlation with y, it is possible through data that x3 has negative correlation. So then it becomes counterintuitive. You cannot explain while individually they were having positive association with the target variable, but when you combine both of them together, the resultant has negative correlation. So then it becomes counterintuitive.
That answers. Thanks a lot.
Anything else?
So I have one doubt, sir.
Yeah.
Sir, how correlation and outliers are means linked with each other, sir?
So outliers are extreme values, and then they definitely impact your overall association. Right? So let's say everything in your data is nicely distributed, like a normal curve, right? And then you try to look at its correlation with the other variable. Most likely, it will be as expected. But suddenly, if you change the value in your the first variable, let's say it's income, and you add someone who has very high income, then it's going to distort your overall correlation. So that is why you need to treat those kind of outliers first before you start your analysis. In fact, there are questions at times, should we do outlier first or missing value imputation? But if you're doing missing value imputation based on averages, then those averages will also get impacted by outliers. So it's better you do outlier treatment first and then missing value imputation.
Thank you, sir.
Okay, should we move on?
Yes,
All
sir.
right. Okay, now we have understood how statistics, domain, technology, they make us better in terms of analysis. Now let's also see, this is another part which I wanted to share, that we need to improve our solution to continuous innovation. Now it essentially means that we need to keep on improving our final solution. Now this could be in terms of accuracy, in terms of customer experience, in terms of business value. It could be in either way. But since we are more focusing on data and analytics, predictive analytics, for now I'm just talking about two key pointers here. First one is how to keep mining data to add more powerful features. Because I believe if we are able to create more and more features, we will be able to capture nonlinearity in a better way. And even if you use a more sophisticated algorithm, it may not be adding that much value if you already have good features. So for feature creation, typically we have two methods. One is scientific method. The scientific methods are more statistical in nature. They're more focused on optimization based on statistics. Now, examples could be if you do transformation of variables. Say there's some variable called say population, and you take log of it. Then log of population may be a better variable than population because it will be dampened. So it's a mathematical transformation. You can use interactions, you can use regression splines, weight of evidence. So many such things that you can try. And here I'm taking an example of interaction because it's easy to understand, visualize. Right? So here, let's say we have some portfolio called installment loan. And we understand that loan to value ratio means higher risk. I mean, if you have very high loan to value ratio, you are going to have very high risk for that customer. So loan to value basically is loan to your collateral value. Whatever you are putting as collateral or security against which you're taking the loan, right? Your loan should not be too high compared to your collateral value. If it is too high, then there's going to be higher risk. Second important variable we understand is number of delinquent trades. So if we are missing out on payments on multiple loans that we have, then that is also an indication of higher risk. Idea is to identify something which is an interaction of these two variables. So let's say we put some cutoff N and L here. If your number of 30 past due trades is greater than N and your loan to value ratio is greater than L, then you get into this quadrant, which is having 5x more default rate than this. So the idea is to do a cross-check based on the cutoff values. Then how to find L and N is something which you need to do statistically. You can also apply some basic logical reasoning and come up with these values. But the point here is that instead of using these two variables standalone, if you combine both of them, then you can generate a lot of value which can directly feed into your model. And you can also explain that this particular section has very high loan to value and very high number of delinquent rates. So this is an example of how you can improve your model further if you identify such variables. Second method is using the business hypothesis. So business hypothesis, as we understood, the domain knowledge or industry knowledge or experience, basis which can we create something which can directly solve the problem. So there are multiple ways. There's recency, frequency, monetary variables, ratio, trends. You can do bivariate analysis of your X and Y and then come up with variables. Here we are taking an example of ratio. Let's say we have two variables and the portfolio here is credit cards. For a credit card, if there are too many inquiries happening, you keep on getting calls on customer care to understand more about the card or about the credit, that we need credit. So then that customer is more credit hungry, and you will see that such customers are likely to default more. And when you see how many trades were actually opened, I mean how many cards were actually approved or given to that customer in last 12 months. So that is also a variable which can help you determine whether a customer is defaulter or good. So the defaulter, actual defaulters are highlighted here in orange, and good customers are highlighted in gray. Right? Standalone, you see, if you just put a cut on the number of trades open in last 12 months or inquiries in last 12 months, you get a mix of customers. You get a defaulter as well as a good customer. Here also you get a defaulter as well as a good customer. But if you try to apply a business sense and then say that why don't I create a ratio variable here, where I see number of trades open in last 12 months divided by number of inquiries that were made in last 12 months. So if someone, let's say, made an inquiry 5 times and you issued the credit card once, so the approval rate is 1/5, which is 20%, and that customer sits here. Similarly, the customer where the approval rate is say 3/10, because there were 3 trades that were opened out of 10 inquiries, and so 30% approval rate. So similarly, you get 2/5 and 6/10. Right? So this way you see that here the approval rate is higher, and here it's on the lower side, 20% and 30%. So these customers are your defaulters in reality, and these customers are your good customers. So earlier it was difficult to find any cut based on individual variables, but when you combine both of them, now it's very easy to find a cut. You can simply put a cut on 40% approval rate, greater than equal to 40%. That is going to give you good customers. So this is another example of how you can add feature or mine a feature from a given data set and try to improve the performance of your model. Any questions on this one?
So Varun, I have one question. Like this is really great, presentation, I will say. The one thing I just wanted to know, how exactly the regression spline we are going to use in this, variable featuring or something.
Again, a very huge topic to discuss. I won't be able to cover it today, but it's one idea that you can search for. Basically, you get some cutoffs, basis which you will be able to create a variable. Let's say max of x comma 5 minus y, right? Something like that will be there, right? So that way you will be able to create, and here x and y are independent variables, by the way. So here you will be able to create some kind of a transformation based on 2 variables by using the max and min. That's one way of putting splines. You can also apply other functions apart from max and min here.
So do you have any, if you can, at the end of the session or later, if you can, will be great if you can please share some sort of, links where we can go through and see all of them, if possible.
No, definitely. Yeah, it's very much handy. I can share it. The EduBridge team, they can share it with you.
Okay, the science method and scientific methods and the business hypothesis. Thank you so much.
Okay. Any other question? Okay. Let's keep moving then. So the next part is we talked about improving the features and adding the features and improving the model. There are other methods also. First, you can upgrade to better solutions, better techniques, I would say. So machine learning, deep learning are very well known, and sometimes we keep on figuring out like what is better, what is not. So I'm just giving you some food for thought. So here, when you try to select the technique, you need to apply some logics. You can consider all the eligible techniques that are there for solving your problem statement. And I'm not sure if you're able to read them, but random forest, neural network, support vector machine, GBM, KNN, Markov chain, decision tree. These are some examples which may be applicable to solving this one particular problem. But you can't just make so many models in the interest of time. Also, sometimes they may not be interpretable. Hence, keeping other factors in mind, you will need to filter out. And you also need to compare at times. You can actually build a first and dirty cut model, and then you can decide whether I could go ahead with an ensemble of them, or how one technique is better than the other. So basis the interpretation, sometimes there are also explainability requirements due to regulatory needs. So all those things we need to keep in mind, and then we filter the techniques further. Finally, once you select, let's say 3 out of 7 or 10 techniques, you can actually go with all 3 of them and see which is more accurate by data. I mean, you can test it out by data, which is more stable, and then you select your final candidate. So that is one way of improving your model, rather than saying that I'll go with Markov chain only and then later on regret that I should have tried random forest. So that is one thing I want to say, that you have to invest your time in technique selection. Second is, when you build the model, you need to maximize the performance and accuracy of your prediction. And there are ways to do it. So there are parameters and hyperparameters that you need to keep on inputting into the model build exercise. So for example, if you go with a GBM model, there are parameters like number of trees, tree depth, terminal node, shrinkage factor, etc. So there's no, I would say, hard and fast rule of applying only one set of parameters. You need to keep on experimenting based on your data set, and of course, based on the computation powers that you have in your software. So that's why you have to also control the input specifications and do some grid optimization, and hence ensure that whatever outputs you're generating are comparable with across multiple iterations, and you are selecting the best model. So whenever you work on any model development exercise, you will never see someone just building one model and presenting it in a story. There will always be multiple iterations, even at the time of decision making. When you go to your stakeholder, he or she would want you to check whether you tried this or not. So you can go with multiple options. So that will make your decision more informed and more transparent as well. People will be able to appreciate it more, because they would know that when you tried this, what happened, when you tried that, what happened. So it's always good to keep multiple options when you finally select the model. The other part, which sometimes we miss out in the haste of building the model, is overfitting. So if you keep on maximizing the performance and that data set is given, trained data set, it may happen that we end up overfitting to the extent that it may not work at all in reality. And that will be even worse than having a suboptimal model on trained data set. Because this model may look optimal, but it will be actually worse than what the second best model is. So you need to be very, very sure about how this model is going to behave in reality. Better way is to go with out of time validation if possible. If that is not there, then at least use some out of sample data to validate your model. It's a standard Bayes and bias and variance trade-off chart that you can see on the screen. So there are two lines here, the train and test, and model complexity increases. As it increases, you keep on adding more and more variables or sophisticated algorithms. Your error on train keeps on going down. But this also leads to a lot of overfitting because the difference between train and test is widening, right? So you have to create the right balance between the two so that you can minimize the errors on test data set and the difference between train and test is acceptable. So this is the right level of model complexity, I would say. If you go with a very simple model here, your train and test both are very close to each other, but here your accuracy will not be that high. The prediction error in both the cases is very high. So keeping these things in mind, you can apply techniques like k-fold cross-validation. You can also apply regularization factors while building the models. So I did not want to make it very high level, and hence I wanted to just ensure that you also have a view of that these things exist. There are methods of applying the machine learning framework, and it's not just a matter of calling functions. It's also a process that we need to follow and then make sure that the results are implementable and the benefits are real. Okay, now we have only a few minutes left. So, you have any questions, or should we move ahead? Okay. Okay, now we'll just close the loop here. So we talked about all these building blocks today, right? Curiosity plus logical reasoning. If you remember, we talked about we need to move away from I know stage to I understand. And then we talked about I can explain. So creativity plus communication is important from that angle. Then we looked at multiple work streams or the building blocks, statistics, domain knowledge, and technology, which are very important for actually solving any problem analytically. And finally, we need to continuously innovate and improve our solution. So these are our building blocks to solve analytical problem or to get into the field of data analytics. The things that we need to build on top of it, right? So, or remember, there are multiple industries in place, and these are just some examples I am sharing: banking, retail, etc. So whenever you feel that you've become master of something, then keep doing that basic check and see that there's not that exists in reality. So there are so many things in terms of industry that you can work on. Then the next layer on top of it is the function. So let's say we pick banking, right? So if we pick banking, then within banking also, if you're only working on marketing function, then you need to see if there is any scope to move to risk, operation, or any other field. So that's another layer on top of your domain. Then after the function, you need to also see what kind of problem or objective you are solving. Right? So within these functions also, there can be possibility that you're trying to solve different problem statements. It could be about growing the business, mitigating the losses, reducing the cost, improving the processes, making them more efficient, improving the experience of your end customer, or any other objective. So this should also act as a, I would say, a checklist for you over the entire span of your career, that what all things you're taking off and what all things are yet to be covered. Then on top of your objectives, you need to understand that there is another layer, which is of data. It may be possible that you're only solving structured data problems as of today, and you have no idea how unstructured data works. So natural language processing is something which you may need to which you need to look at. So natural language processing has to do more with how to process our natural language, which is the written language, or I would say the way we speak, audio or speech analytics. That also comes under NLP. If you look at the computer vision, then it covers your image and video analytics. So that is another field which is emerging a lot. In fact, it has evolved a lot over last 4 years. So this is another area. If you have not delved into it, it's time to start looking at it. Then we did talk about the different kinds of analysis or the spectrum of analytics: descriptive, diagnostic, predictive, prescriptive, and cognitive. So even let's say you are in banking, marketing, growing business, structured data, but you are solving only one part of it, which is reporting what happened. It's important that you start diversifying your skill set and move to diagnostic, predictive, and so on. So if you keep all these things in mind, you will end up creating a very bright and good career, solid career. And these are our building blocks, as I mentioned. The foundation has to be strong. In fact, this is what you are from within, and what you see on the top is what everyone else sees. So if you are strong from within, then you will be able to perform here. This is your play field actually. So any questions on this before we end the session today?
Hi, Varun sir. I have a question. Actually, I'm not from data analytics field. Right now, I'm working as an assistant manager in Genpact. I want to move towards data analytics. I have a good understanding of Microsoft Excel, and I have started learning Power BI through one of the online mode. So, what do you suggest? Like, what should I do? In order to excel myself in the field of data analytics, as I want to make a career shift in that direction. So, what do you suggest, sir?
First of all, I think you must have picked some domain, right? And that is why you are trying to analyze data of that particular domain, and you are getting some understanding of it.
Correct. So currently I'm from collections background. So I'm, but I do not want to limit myself to a certain domain. I mean, I can move forward. I mean, analytics being the base, I can move towards any direction, like in insurance, hospitality, retail, banking, or anything.
I know. I mean, know Genpact very well. So I would say that my suggestion would be to first of all talk to your supervisor and see if you can get more opportunity in the same organization,
Right.
and to do a shift horizontally. You can look at some other field if you want, if not collections. And can you progress further from say descriptive analytics to diagnostic? Right? So when you are reporting it in Power BI, I'm sure you must also be trying to analyze and do commentary on it, like what happened, why happened. But you are not into predictive at all, and gradually that should be your objective if you want to progress further in solving complex problems.
Right.
The rest is real, market is all open, but before actually expecting that people will accept you as a problem solver, it's better you start acquiring that skill. There are so many self-study courses and online edtech courses. You can probably look at them, but keep in mind that there are so many things out there, and one particular uh, point is just actually a point in the whole picture. So it's up to you how you want to move from that. You want to remain in banking, you remain in banking, but then try to at least diversify your statistical skills and data processing skills.
Okay. Okay. Thank you, sir.
Audience, do we have any more questions?
So yeah, I have one. So thanks, Varun, for walking us through an amazing presentation, and talking about all these case studies and how you are leveraging data analytics within Excel. So just wanted to get your thoughts around how the mid or senior level people in analytics can move to a leadership role like the way you are playing within Excel. So what sort of a trait people should acquire to get to that sort of a position?
Yeah, so we did talk about it briefly. So are you more from statistics, a domain, IT? Can you share a little bit more?
Yeah, so I'm into analytics only. I've been working with Optum right now,
Okay.
and I've been in the field for around 10 years now.
Oh, great. So you know the secret sauce already. So the part here is that, let's say if you are lagging behind in certain part, let's say you do not know about how to solve a problem through advanced machine learning algorithm, or if you do not know how to do it on cloud, or if you do not know how to solve a particular business problem, those are the areas you would need to start looking at so that your experience gets diversified. This can act as a checklist actually, and I'm not saying that you need to achieve everything, right? It's humanly not possible to look at all domains, but whatever domain you are comfortable with, at least within that domain, try to expand your understanding more. See, if you're already working on analytics, are you providing, say, some strategy kind of solutions, or are you providing predictive modeling kind of solutions? So those are the questions you need to ask yourself and see if you can upgrade yourself in terms of data, in terms of the statistical techniques.
Sure, that helps. Yeah, thank you.
Right, and just one more point. So as an analytics leader, eventually you will become. So people will expect answers, will expect guidance every now and then.
Yeah.
So it is going to be very, very important that you understand other domains, or you understand the other side of the story as well. So for that matter, I do not know all of it, right? So, but still I have basic understanding of some of it and advanced understanding of some other topics. So that's how it works. I mean, if you aim to become master of everything anyway, you will not become. So I don't want you to go in that direction.
Sure, thanks.
Okay.
Do we have any more questions? So Govind is asking, how could it easy to switch career from manual testing to analytics?
Manual testing to analytics. Okay, so see, when you're doing testing, you are applying logics, right? In fact, you need to act like a hacker. It requires a lot of, I would say, out-of-box thinking to see how the system will get broken. So you already are excelling at one of these skills, which is logical reasoning. Start reading a little bit about statistics, because I believe statistics will be something which you may be lacking. But that is not a problem. There are so many courses, videos, you can go through them, and maybe you can start with some data mining projects. Kaggle is very well known. You can just pick one data set, look at the discussion forum, see how people are solving those problems, become comfortable. And once you acquire that confidence of participating into one or two competitions, I believe you will be more confident in applying, or even, I mean, I would not encourage you to leave your company. I would say that try to find a different job in the same company if possible. That is going to be in sync with what your supervisors also want and your organization wants.
Govind, I guess you've got your answers. Any more questions, guys?
Yes, ma'am, I do have a question again.
Yeah, please.
Yeah. Hi, Varun sir. It was an amazing presentation. Got to know more about data analytics. Okay, so I'm a software engineer. I am working on currently I'm working on developing the application, and I do have like Python and JavaScript knowledge. So I'm like doing a data analytics course from same like EduBridge. So this was like very advanced for me to understand whatever like the explanations you give. So I would like to know like how I can more improve my statistics analysis. I do have programming knowledge, but like how I can improve. Are there any modes or any kind of a flow or a map or a roadmap to improve the statistic analysis, so that I can solve the problems in a statistics using statistics.
Sure. So I think every single work stream we talked about has basic one-on-one, 101 kind of concepts. So I am also from statistics background, by the way, so I can help you here. Start with a very basic book. And if you like econometrics, you can probably go with Damodar Gujarati. So it would help you understand the basics of what econometrics is all about. What do we mean when we say y is a function of x? Right? You know it mathematically, but probably don't know it statistically, and hence you're struggling a bit. But over time, when you start developing those concepts of univariate analysis, bivariate, multivariate, correlations, all those things are not difficult. So if you spend some time, I think within 3 or 6 months, you will be very comfortable with statistics.
Thank you, sir. Thank you so much.
So Danish is asking, I am a 1 PUC student. In which field should I go to become a data analyst?
Okay, so you know your building blocks now. You know the building blocks. So wherever you feel you're comfortable with, at least get started from there. So, and again, I'm not promoting any specific area here, but let's say you do not understand the basics of probability. So then it's important to get to statistics. If you do not know how to write a do while loop, then you need to probably also start looking at how to write logics. So you understand now, and domain is something which you will get to know once you actually start working somewhere. So if you join a bank, you will know more about banking workings. If you join an automobile industry, they will tell you about how it works. So you should not be worried so much about the domain part as of now at this stage, but try to have your statistics and coding and programming concepts improved.
Okay, sir. Thank you.
Hello, sir. I have a question related to that outliers.
Yeah.
And in outline in Python, we are using different method for finding the outliers, like that set score, box plot, and IQ are also we are using. Which method we can tell, sir, which is more accurate, and which can we can blindly which method is most accurate?
No, there is no such thing. Actually, you're very right. And there are so many methods, and the reason they exist is they work in some cases, and some other method work in some other cases. Some people even use a very simple way of capping the values at P99, and it works. But I would not say that you need to go with any one specific method. There are complicated methods as well. Mahalanovich distance is something which you can look at, but knowing about them is better. For now, it's important that you practice some of these methods and see yourself which is working better on your data set. Let's say you try 3 different techniques and build the same model with the same technique basically, and then you see which model is working better. Then you will develop a viewpoint.
Okay. Okay, sir.
Okay. These outlier treatments are very much driven by what cutoffs you choose. So within that also you will probably need to do some kind of parameter tuning before jumping to conclusions.
Okay, because when I was working with 2 to 3 data set at that time, set score is having some issues. I found that. That's why I asked.
Okay.
Okay. Okay. Thank you, sir.
Oh, I guess we are done with the questions here. So towards the end of the session, I would just like to appreciate and express my heartfelt gratitude to Mr. Varun Aggarwal for this enriching session, using the real life examples and making our audience understand and clear their concepts. Also, I would like to thank our audience for some awesome questions and being so interactive, and it wouldn't have been possible without the speaker and the audience as well for the session. So thank you so much, everyone.
Yeah,
so yes, thank you, Varun sir. So at EduBridge, we believe that improvement and keep growing is a key concept for everyone. So I would like all the participants to please fill in the feedback form that we have prepared for you. So I'm posting it in the group chat. Please fill in the feedback form and let us know what improvements can we make and how did you feel about the session. Please do that. And also, I would like to tell everyone that EduBridge offers certification and postgraduate certification courses in data analytics. If someone is interested to enroll or ask any questions, they can share their details, and our career coaches will get in touch with them. And regarding the participation certificate, we will email it to you by next week. So don't worry about that, and you will also get the recording after it is edited. So thank you so much, everyone. I'm keeping this session on for next 5 minutes. Please do fill in the feedback forms and let us know how was the session.
Okay, Pratibha, thank you for this
Thank you
wonderful
so much, sir. Thank you so much.
Thank you. Bye.
Have a good day. Bye.